Hello and welcome to my video, lesson 8.0, unit circle and radians. This is going to be the part A video. Please continue to watch the second part after this one. Okay, so we have a few different things that we have to remember from 20-1 in order to get to the unit circle. And that is basically based off of these special triangles here, the 30, 45, and 60 degree triangles. The 30 and the 60 are the same, just kind of flipped versions of each other. But the concept goes that we have, the easiest one to understand is the 45. So if we have a 1 and a 1, then if you use Pythagoras' theorem, it's c squared equals a squared plus b squared. So 1 squared plus 1 squared is 2. So the c side, or the hypotenuse, is square root of 2. Okay, this is fantastic because it allows us to find the SOHCAHTOA rules getting the trig ratios. So sine 45 is 1 over root 2. Cos 45 is 1 over root 2. Tan 45 is 1 over 1, or just 1. So this is great. Let's go on to the red triangle, the 30 degree triangle. Now this is the 1, 2, root 3 triangle. That's the rule, 1, 2, 3. And so we're going to use a 1, a 2, and a root 3. So the rule here is that 2 is the biggest of those three numbers. Root 3 is actually less than 2 because root 4, square root 4 would be 2. So square root 3 is less than 2. Okay, so using this idea, what we can now do is we can go opposite over hypotenuse, which is 1/2 for sine. We can use root 3 over 2 for cos, and we can use TOA, so 1 over root 3 for tan. Okay, so the same concept also applies for the green 60 degree triangle. It's 1, 2, and root 3, so the same as before, but now it's flipped. The opposite is root 3 over 2, the adjacent is 1 over 2, and the hypotenuse, or the opposite over adjacent, is root 3 over 1. So you can see that it's the same as the red triangle, red trig ratios, except flipped. Now, this is fantastic news. A lot of good information, but how does this apply to the unit circle? So here's our unit circle. And why do we call it a unit circle? We call it a unit circle because the radius of the circle is 1, a unit, 1 unit, 1 radius. So if we go ahead and find this first value, this is 1, 0, right? So that's the position that's at if you look at a coordinate. And this is at 0 degrees. Okay, so let's just continue this pattern. So this is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Okay, so there's a bit of a pattern here, and so now we can write down the coordinates of each of these. So this is 0, 1. This is -1, 0. This is 0, -1. And then we're back to the beginning. So the radius of this circle is 1. You can see that on the right, the top, the left, and the bottom. So if that's true, then what we're going to do with our triangles here is we're going to make these have a radius of 1. Well, what does that actually look like? What does that mean to have a radius of 1? Well, this blue one, if we go from here to here, well, this is the triangle that we had over there, but the radius is 1, or the hypotenuse is 1. And we can see that again for this green one, which is going to have a hypotenuse of 1, and this red one, which is going to have another hypotenuse of 1. So all of them have a hypotenuse of 1. This is key. So this is a 1, this is a 1, and this is a 1. Okay, so we're going to erase the extra part here we don't need. There you go. But that idea that the hypotenuse is 1 is critical. Now, if we are to have the same trig ratio as before, which we know it's sine of 30, so it must be the same trig ratio, then what we have to have is something, like if you think about sine is opposite over hypotenuse, then sine of 30 must be something over 1 to give you back the same value as before. So it must be 1/2 over 1, which means the opposite side is 1/2. If you try that same thing with the cos, it's the same idea. It's √3 over 2 over 1. So the adjacent side is √3 over 2. So we can follow this logic down for each of these, and this is going to end up being 1 over √2 from the sine. This is going to be 1 over √2 from the cos. This is going to be √3 over 2 from the sine, and this is going to be 1 over 2 from the cos. So we can now generalize this rule to something quite amazing. Okay, we can generalize this and say that sine theta equals the y value, the vertical value on our unit circle. And cos theta equals the x value on our unit circle. This is fantastic, but what does tan equal? Well, tan is opposite over adjacent, which in this case is y over x. So tan, we can now say, is y over x, or sine theta over cos theta. Okay, so with all that information in mind, we can now state some wonderful, wonderful facts. So over here, these are based off of the angles that we had in our triangle. So this is a 30, this is the 45, and this is the 60-degree angle. Now for the 30-degree angle, we know that the x value is √3 over 2. We can see that in our triangle. And the y value, we can also see in our triangle, is 1/2. If we see that for the 45, it's 1 over √2 and 1 over √2 for our x and for our y. And then for our green 60 degrees, it's 1/2 comma √3 over 2. So this is fantastic. I'm just going to make a little bit of an aside right now, a little note, that a lot of people will write this as, so this is what I wrote, but a lot of people will write this as a rationalized denominator. And both are perfectly acceptable answers. For me, this one, the one that I wrote down in blue, makes more sense. But all that we did to rationalize this is multiply by a √2 on the top and bottom, so the fraction never changed, and now we don't have a radical in the denominator. So you'll see this happen a lot, but I'm going to stick with the blue version of it. Okay, so we were able to get our first quadrant, but we have a rule back from 20-1. It's called the cast rule. And this tells us that cos is positive here, all of them are positive here, sine is positive here, and tan is positive here. And that's a fantastic rule if you want to memorize something, but no one really likes memorizing, especially in math. So what we do instead is we understand a rule. And the rule is cos is x, sine is y. So cos is negative over here, because that's where x is negative, and cos is positive over here because that's where x is positive. Sine is positive over here, and sine is negative over here, again, because that is where y is positive and negative. So if we can follow that same rule around, we can do some amazing stuff. I recommend you pause the video here and see if you can figure out the green, blue, and red for the other 3 quadrants. All right. So at this point, we have all of our little lines drawn, and the question is, what are the different angles? Well, the angles that we have, 30, 45, and 60, are the reference angles. So we're going to use those to get our results. So in this case, for the red one, it's 150 because it's 180 minus 30. Over here, it's 210 because it's 180 plus 30. Over here, it's 330 because it's 360 minus 30. Okay, let's take a look at the green ones. So this is going to be 120 because it's 180 minus 60. This is going to be 240 because it's 180 plus 60. This is going to be 300 because it's 360 minus 60. Now for the blue ones, we're going to have 135 because it's 180 minus 45. This is going to be 225 because it's 180 plus 45. This is going to be 315 because it's 360 minus 45. Okay, now what we can do is we can go ahead and actually label all of the coordinates for each of these values. So this one is going to be the same as what we had before. So this is kind of the key, okay? The green ones are the exact same. So 1/2, comma, root 3 over 2 as what we had before. You can literally copy this to all of the positions. But what's key is what we talked about before. We need to consider where they are positive and negative. So on the 120, is x or y or both negative? Well, the x is negative. On the 240, are x and y or both negative? In this case, both are negative. In 300, x and y are both. It's the y that's negative. So if you follow this rule, you can actually go ahead and do all of these examples. So here we're going to do the blue one. It's going to be 1 over root 2, 1 over root 2, and the x is negative. Over here, it's going to be negative 1 over root 2, comma, negative 1 over root 2, because both are negative. In this one, it's going to be 1 over root 2, and then negative 1 over root 2. Okay, the red ones are all a reference angle of 30 degrees, so they are going to have negative root 3 over 2, comma, 1/2. This one's both are going to be negative, so root 3 over 2, negative 1/2. And this one, the x is positive, but the y is negative. And so hopefully what you can see with all of these examples written out is that the unit circle is based entirely on the special triangles we already know about. So nothing new has really happened other than we've got a circle now with a radius of 1. So all of this is basically the same as 20-1, but we're going to be adding a concept called radians, which you're going to talk about more in the next video. I hope this video helped, and good luck.